Okay, so let's make a start. Hello and welcome to this webinar, everyone. Thank you all for joining us. My name is Stuart Scott from Cloud Academy, and today we should be focusing on and looking at the best practices when it comes to monitoring and troubleshooting your serverless applications. Now, over these past few years, there's been more and more organizations that have adopted a serverless framework somewhere within their cloud infrastructure. And this rapid growth has led to more and more tools and services being designed to assist with the ongoing management and operation of these solutions. And these provide us a greater and more granular insight into our serverless applications when compared to those that are offered by the cloud vendors themselves. So looking at the agenda for today, we should be covering a quick introduction to serverless itself. Then we'll take a look at some of the challenges that exist when working within a serverless framework before diving into serverless observability, where focus will be given to monitoring, logging, tracing, and alerts. Now, today we are lucky to have with us on the panel Ribenzaft, the CTO of Epsagon, and also Peretz, a software engineer also from Epsagon. So thank you both for joining us. And luckily for me, these guys are going to be doing most of the talking today, and they will guide you through the agenda topics in detail. So over to you guys.
Thank you very much, Stuart. Thank you very much for having us, and thank you everyone for joining in. It's a pleasure to be hosted and talk about serverless. So let's get started with what we came for today. So we'll start with explaining a bit about the serverless ecosystem, or what is serverless. So we saw the evolution of the infrastructure, or the way we deploy our code to production, starting from bare metals, and then VMs came and kicked the old cloud era in, and then containers were also a great benefit for us, the developers. And now comes the function as a service, which is a bit different, but it makes life much more easier because it handles the scale, it handles the infrastructure management. And this is just the function as a service. When you're talking about serverless, it's a more of a broader term than that. It's also the managed services and managed APIs that are being used for you. So instead of managing my own database or my own message queue or my Twilio, Stripe, Auth0, and so on, all is part of an agenda that we don't want to manage the infrastructure, but rather to focus on the business logic. Now, the properties of serverless applications are much more distributed and much more event-driven. It means that, in essence, we don't have anymore this huge monolithic application that run on a specific server. But other than that, we've got like multiple resources, multiple compute parts and storages and web servers and message queues and databases and so on. And each one of them utilizing more and more APIs, one for payment, one for messaging, one for SMSs. And some are even external ones like Redis and Mongo and Kafka. So all of these ones are building our full serverless application that can be run in production in really high workloads. Now, this function as a service is great, but it's introducing some new limitations. I think the first and the foremost one is the limited running time. So it means that each function can run for a certain amount of time and cannot cross that threshold. For example, for AWS Lambda, it's only 15 minutes.
So would you say, sorry to interrupt, so would you say, do you see the limited runtime as an inhibitor? For example, are you likely to come across scenarios where like the 15 minutes for Lambda, for example, is not enough time to run your code?
Well, yeah, the 15 limit actually is something that they raised recently. And honestly, I think that usually when people go from a monolithic application to serverless, it may be much easier to take the entire chunk of code that takes a lot of minutes and put it in a Lambda right now. But I think it's not that good practice because you want your functions to run fast. And once you have a function that's run for a few minutes, this probably means you have some design issue or something is wrong with the way you design the system.
Yeah, it's like trying to stick the old habits with the new infrastructure, which can work, but initially you want to design an event-driven system that acts fast.
Some cases it's very necessary, like if you have a huge computation, but in most cases it's not.
So it's kind of working with re-architecting your code, essentially.
Yeah, it should be for most cases.
Okay,
so
thank you.
Yeah, other than the limited running time, there is also limited memory. So currently for AWS Lambda, it's 3 gigabytes. It means that our code cannot use more than 3 gigabytes of RAM, which, it's a lot, but sometimes you can even cross that threshold as well. And I think also two really new things that came out as part of the function as a service is first that each function is ephemeral and stateless. So it means that you need to utilize more and more external APIs to store the data or to store a state or to do something. It means that you have to utilize some APIs out there. And last but not least, it's a well-known phenomena called cold starts, which means the time for the first VM instance of the Lambda to take place. So usually there is a warmed up instance that takes care for request, but due to utilization that the cloud vendor is doing, sometimes it drops off an instance, and now when new visitor requesting this information, they will need to cold start again your function. So there is not much to do with it, but you need to bear in mind that it can happen and it can affect the performance of your users.
Yeah, it also comes, I think the main change in serverless there are some very huge challenges that as opposed to being run on a server, you can't, SSH and go and see the correct log file and try to understand what broke your code. Second thing is troubleshooting is way harder now because your software is much more event driven, and trying to keep track of all those events happen together asynchronously and looking at the picture as a whole, it's very difficult, along with unpredictable cost and the compute limitations.
Yeah, that we just talked about. Yeah, so here exactly come the Epsagon technology. So for Epsagon, what we're doing first and foremost is the automated instrumentation and distributed tracing. We'll soon talk why it's really important in the serverless era, but rather than seeing one process transmitting a message to an MQ and then someone else reads it in 3 different processes or 2 different logs and so on, you want to see that in the same place, and you want everything to be automatically instrumented for you. We also provide visual debugging and cost tracking, which, for serverless, it can be very unpredictable to understand what will be the bill by the end of the month. When you had an EC2 instance, it was pretty easy. No matter what you did, you would end up with the same pricing, but here it's really different. And also in serverless, mostly we want to focus on our business flows rather than just list of resources. So Epsagon provides that as well.
As a general kind of practice, when we was talking about the serverless methods a minute ago and being unpredictable costs, I think it was on the previous slide. Are you able to implement specific security controls or throttling methods to prevent your costs from spiraling out of control? For example, should a function be compromised? Is there anything that can be used there?
Yeah, so there are 2 reasons why the cost is very unpredictable. First, because you're open now to someone that might DOS or DDoS your Lambda function, and you would pay for it because, originally you would get throttled, but here AWS takes care to handles all these requests, so you'll pay for them. But actually, even if it's not DDoS and it's your own traffic that's just getting higher and higher, hopefully the applications that we are building are built for scale and for a large amount of users and requests. So you're getting more and more traffic. It means that you will pay for that more, not similar to EC2 instance where either this request wouldn't be handled or you pay the same amount of price by the end of the month. I hope it answers your question.
Okay, thank you.
Yeah. Now we came here specifically to talk about observability, so we'll start first with what are the pillars of observability, starting with monitoring, then logging, tracing, or specifically distributed tracing, and last but not least, reviewing the alerts as well. So let's tackle them one by one. Monitoring, I think it's the basic unit that we need to understand when we're trying to observe a system, and it's honestly answer the question of, is my system working properly? Now, is my system working properly? It's sometimes can be hard to define because it varies from one system to another. And actually in serverless, we need to know what we want to monitor. So first,
what is exactly your system?
Exactly. So we understood that the system is not just the functions, it's all about the resources and the ecosystem, but specifically some key metrics that used to being monitored is first the amount of requests or traffic, and out of them the amount of the ones that yielded an error result. So it means what is the health of our system, and also the amount of time it takes to request to be processed. So this is the performance out of the monitoring. And also in general, just the amount of traffic. So we'll be aware of how much traffic are we ingesting, what's the traffic rate, and so on. So we'll bear in mind what's going on in our system. Now, specifically for serverless, so AWS offers the AWS CloudWatch metrics. So they're available for every function in the AWS console, moving from the configuration tab to the monitoring tab. And you can see all of these boxes over here that we will review. And for each one of them, you can configure for how long do you want to see them. So starting to review one from the left part to the right part. So starting with the number of invocations, this tells us how much traffic or how many invocations there are to the Lambda function. Also Lambda duration, so it being presented in minimum, maximum, and averages. But I think it's interesting more to see percentiles sometimes, which also being offered, but not in this screen, because percentiles might make more sense rather than maximum. So we'll be able to see how the top 10% of our requests are being handled in terms of performance.
Though this is a pretty convenient screen to watch all those metrics together, and you can also later on set like alarms specific for those metrics with CloudWatch Logs, which we'll show later on.
Yeah, so with that, we can also see the error counts and the availability, the throttled request count. So AWS can throttle request if you cross the limit of the amount that you can handle at a certain amount of time. And also the iterator age, which is relevant for stream-based events. For example, SNS, SQS, DynamoDB streams. And it means that the longer it gets, this is the chart, the longer it gets, so it means that we've got a bottleneck. It means that we can't process as fast as the ingest throwing new messages. So we can see in this example that it's getting slower.
This is a
and slower.
classic, if you can see in the picture, the iterator age on the right, this is a classic case where you have a Lambda function that is being fed by an SQS, and that function has some kind of a bug, and every time it gets that package, it raises an exception, and it's being infinitely retried by AWS.
Yeah.
So the iterator age is going to be increasing until you're going to fix that bug. This
Yeah.
is a great indicator to know if you had an issue.
Yeah, definitely. Now for serverless, we saw that we need to monitor some more stuff for the function, starting from timeouts to out of memories, and then also the concurrency limit, so we'll be able to understand, do we got a spike? Are we handling the same amount of traffic, or is there an increase or a decrease? Also the cold starts, we want to see them to understand how much impact they have on our functions. And also retries. I think retries, it's an interesting behavior that happens in function as a service services. So for example, if the function is being triggered by an SNS and this function fails, AWS will automatically try to retry the same request 3 times. This can be configurable, but you'll need to be aware of it and maybe make your function idempotent, so there won't be any changes between different similar invocations.
So a quick question. So have these additional monitoring metrics become more apparent as serverless has become increasingly popular and users have determined that CloudWatch doesn't quite catch everything that's really beneficial when the serverless solution is business critical?
So I think that CloudWatch provides a great infrastructure for logging and creating monitoring on top of that. It's less about the application layer that he wants to monitor. So timeout, it's an outcome of using function as a service, and not like arbitrary log line or a simple metric that you can see. So it's, on top of CloudWatch, you can definitely build everything. The Epsagon is to some extent built on CloudWatch streaming data. But AWS gives great infrastructure to build amazing software, but you need something dedicated in serverless to answer that for you.
Excellent, great, thank you.
Perfect. Now, specifically, Epsagon offers here a much more dedicated view for functions rather than getting into each and every function in the AWS console and trying to understand if something bad happens. So Epsagon offers a list of all the functions with their ID, like who triggers that function, what is the function name, AWS account, region, and runtime. For each and every function, we also show performance data, so including invocations and errors, timeouts and out of memories that we saw that are unique to serverless, last invocation, average duration, and monthly cost. So this is great for detecting maybe if something is not performing well and it's going to cost me by the end of the month much more than that. And everything here is presented in like the period that we're selecting, so we can understand how the function is performing according to that time frame.
Is the monthly cost based on an average over a set time period and so fluctuates, or is the total cost the total cost to date, basically?
Yeah, so we actually, once you click even the 7 days or 24 hours, we take that exact 24 hours and try to estimate the monthly cost. This is useful like for cases where you just deploy the function and you want to see how much it will affect you by the end of the month.
I see. I'm with you.
Yeah. So the next pillar of observability is logging, and logging is we can monitor our functions, but at the end of the day, if we want to start to investigate a problem, we all as developers we use the logs. We add some prints, and this is a pretty useful tool when you try to debug. So I think maybe we can talk about how you can leverage the logs in order to be able to investigate faster. And for me, you must cover the most basic things as every time you have an operational failure, print the exception message or the traceback or the event error. There's some useful data there for investigating, and of course custom metrics for your own business logic in case your function runs and you want to print something that is also crucial for your business logic.
Yeah.
And additional verbose information is also good because you can later on look for a client ID or token and find that exact invocation that made your code crash.
Yeah, I think it applies to any serverless, for any application in general that you want to log as much data as possible. But in serverless specifically, everything is ephemeral. So if you haven't logged something at the same moment, for example, the client ID or any data that you want to be able to investigate afterwards, you won't be able to access it anymore. It's not being stored on a /TMP or something. It will be obsolete in a matter of minutes or hours from the time it happens.
Yeah, let's talk a bit about how we can find those logs specifically in AWS. So AWS offers the CloudWatch logs, and when a log has been when a print has been written by your Lambda, it's sent to the std out, and then the CloudWatch logs asynchronously writes them for each function. They have their own log group, and for each log group, for each VM instance, there's another log stream.
So you're saying, in other words, that I do console log or print, and AWS takes care for taking it to the log for me.
Yeah, AWS doesn't add any additional overhead once you send the log. Mm-hmm. And maybe we can go back here. So yeah. I think most of the people here that use AWS know this screen and know how hard it is to find.
Yeah, a nightmare, living nightmare.
It can be nice if you have like a few running a function that is being invoked periodically every 10 minutes, so you can keep track. But once you have a very high throttle, high frequency function, is very hard, especially if they run in parallel.
Yeah. So how do I know which log stream to go to when I'm troubleshooting?
I think you don't.
Yeah. So yeah. So the answer is that it's really hard to guess. I mean, it's a guessing game because just so you'll be aware, every log stream is being created for every new VM instance that AWS or actually Firecracker initializes with the Lambda. So every time a cold start happens, a new VM instance is being initialized, or the opposite actually, and then a new log stream will be created. So if you got high concurrency, you'll have lots of logs in the same time. So it's somewhat really hard to troubleshoot or to explore and filter the exact log that you're trying to look for, because you first need to understand at which log stream will it be according to the time that might help you, but not always, and then try to filter it there. So it's not that easy.
Yeah, I think in terms of best practices to tackle that issue is to stream all your logs to an external log provider. AWS offers you to do that, and without it doesn't add you any overhead when your function runs, and you can stream it either to AWS Elasticsearch or to additional Lambda, which is, I think, much better use case for that, because then you can use that Lambda to stream it to any other log provider you want.
Yeah, so in general, I think the agenda is take the logs to a proper log searching solution like Elastic or any other managed service as well, but something that will allow you to filter and aggregate logs in a more easier way.
Yeah, so here we can see the exact flow where Jan Chui also wrote a great blog about this. We can share the link after this meeting.
Yeah.
So when the Lambda is writing to the std out, it's being asynchronously reading to the CloudWatch logs, then you can invoke a Lambda. And that part, I think, is powerful because you can also manipulate that data and structure them in one unified structure, so you can search it much more efficiently in whatever log aggregation service you would like.
Yeah.
In Epsagon, we also try to tackle this issue and make this much more convenient for everyone. So in our own function screen, we show invocations, and for each invocation, you can scroll to the exact CloudWatch log.
Yeah, also for each invocation, you actually see the time, duration, and used memory, so it's much easier to navigate and look for a specific issue at a specific time frame or a specific performance, and then get the CloudWatch log instead of trying to sift your way through log groups and log streams and so on. So it makes it much more easier.
Yeah, and then once you find the log, you can also search within the log and hopefully get much more better understanding of what really happened in your function.
Yeah, but I think the problem that rises with logs, specifically in a very highly distributed system, is that sometimes you can't correlate logs between different services or different resources. Exactly. So actually here exactly comes the tracing, or honestly distributed tracing, that helps us to build a picture and pinpoint where failure occurs, or not even a failure, but for any case to understand a real root cause analysis of it. So specifically distributed tracing or a trace will tell us the story of a request as it propagates through a distributed system. Distributed system can contain lots of services. So in our example on the left-hand side, we've got a client, load balancer, and a few other services such as authentication, billing, and some other ones. Now a trace tells us that a request came from the client to the load balancer, then authenticated, returned the response. And rather than having 5 different logs and trying to correlate between the same one that the client sent and the one that's corresponding to his authentication, we can just see it from one end to another as a single story. And also, an example of a serverless, so it's the distributed tracing is the method of collecting both asynchronous and synchronous events. So for example, if I put a file in S3, or I'm putting an item in a DynamoDB or an SNS, SQS, any resource that I'm using, so I want to build a bigger story out of it.
Maybe the simple way to describe it is the ability to be able to take asynchronous events within the same execution and collecting that together.
Yeah, and correlate them. So in general, what we want from distributed tracing is to be able to collect these traces, hopefully automatically, and then gather them as a whole execution or a full story from the beginning all the way to the real end, and not just a single service end. Now, there are ways to implement distributed tracing. There are great open standards called Open Tracing and Open Census that define a structure for how to trace and how to instrument this kind of distributed systems. Specifically, we'll focus on open tracing. So it says in general, for every service, you'll need to wrap up the request before and after. So before the request, you can see on the right-hand side, you'll get the relevant headers, the relevant data, the one that we're calling to. And once the response arrives, we'll be able to parse how long it took and get all the information from the response. And this can be applied at the end of each microservice. So when microservice crosses boundaries to a second one and gets into that, so they'll share the same trace ID or transaction ID altogether. I think these standards are great, but they require high maintenance. So just an example, to capture an HTTP request in open tracing, we see that we need all this code, and we'll need to add the before request and after request every time we're calling something. So it requires constant maintenance over our code, and there is potential of errors, or actually a potential to miss errors if we don't instrument them at the right time. And I think in general in serverless, we're talking about the development velocity. So the ability to ship fast and don't handle all the infrastructure and all the surroundings. And I think a side note to that is that we want to utilize managed services as much as possible, because we won't build ourselves the best database. We won't build ourselves the best web server. We're using external solutions that giving us the solution, the proprietary solution that we need for our project. When you instrument distributed tracing correctly, specifically with open tracing, you can use Jaeger. So Jaeger gives a nice visualization of a trace going through all of the services. So starting with the front end all the way to the MySQL database and then the Redis. So everything is visible, so you can detect performance issues or errors that happens across any service. This is a good way to see it in a waterfall chart, because then we understand quickly where our request is spending most of its time throughout its lifespan. For serverless, so Epsagon offer a bit of a different approach. So rather than looking at tons of logs or just seeing performance, Epsagon offer a better visualized way of understanding a chain of events. So on the left-hand side, we can see a transaction example. Transaction is a chain of traces related to each other. In this example, we can see an API gateway triggers a Lambda function, which called auth0 for authentication, then puts a file in S3, and you can see it goes all the way. And for each item that we'll be able to see, we'll be able to see the exact data relevant to it. So what was the response body, the status code, the logs, and everything that was collected throughout the lifetime of this request.
Do you see that having a graphical representation like this of the process of your requests and being able to see where a request might fail help those who need to be aware of production issues but do not necessarily have the technical background? I mean, personally speaking, I've found that creating diagrams in the past when trying to explain an incident can really help people understand where the issue lies. And it looks like this does exactly that, kind of creates a diagram to help.
Even, you know, developers, we see is code and terminals. We love seeing, as humans, things are more visual.
Sure.
Also understand better, because specifically in serverless, once we took all those microservices we had and we broke them into even much more smaller pieces, I like to call them nanoservices. It's very hard to keep track of who's calling who, and especially even after you take all those distributed traces, you need to visualize it. So Jaeger does
really helpful,
and we do it with a graph.
So there is a famous saying that a picture worth 1,000 words. So at Epsagon we say that a graph worth 1,000 logs. It makes more sense to view that in that way and not just 1,000 log lines.
So I think that once you can see the errors, you want to maybe just move to the next pillar of observability. So alerts is where we want to be able to get all those messages that we're about to fail, and we want to get them as like push notifications. We don't want to keep monitoring all day and spot for errors. We want to be alert when something is about to break, and I think maybe in most three main subjects as system failures, every time I see the function is about to get down or is down, I want to be notified.
Mm-hmm.
If my service is experiencing any unexpected traffic, I want to be aware of it. So I will know if I have any scaling issues. I want to have any suspicious spikes.
Yeah, exactly the spikes that we talked about before, when someone might try to DDoS us, or is a spike in the traffic that we need to explore. So you need to be alert of it.
Yeah, and also it can monitor us for any performance issues. If my function is starting to slow down, I want to be also aware of it, because I know that something in the last deployment affected my performance, and also going to affect the entire system and how my clients see it. So AWS offers us the CloudWatch metrics and also the ability to alert on various CloudWatch metrics. I think it's really useful.
Yeah.
So once you go to the AWS CloudWatch alerts configuration, you can define any threshold you want and have it watch on any CloudWatch metrics, and also once such issue occurs, it sends you a notification to an SNS, and later on that SNS can trigger a Lambda, and from there we know that it's pretty much whatever you want to do.
Yeah, I think great examples for getting alerted on. So for example, one can be, I don't want to monitor a specific error, but I want to monitor excessive amounts of errors. Like in this example, 10 errors in 10 minutes, something that might makes more sense for instead of just one. Also, maybe when I know the expected traffic should be, I know, thousands of invocations per day, but all of a sudden I'm getting just 10.
Yeah.
It means that something not working properly. I'm not getting enough data as I expect. And also performance. I know that my function should respond in sub-second duration, and if it takes more than a second, I don't care. 1 second and few milliseconds extra, I want to be notified for that. So all these examples are great for, keep track of bad things that happens in the system.
Yeah, and I think another good practice is to actually have that SNS being sent to you once an alarm is occurred, and being sent to raise a Lambda, because in this case you can ship it to a PagerDuty or Slack or any other issues aggregation service.
Yeah, each team got his own special treat that he would love to get it. I know personally I love to get Slack alerts at 4 a.m. in the morning. It's my personal favorite.
Who doesn't?
Yeah, so we've covered all the topics. We would love to show now a quick live demo of Epsagon, so you'll be familiar with what a dedicated solution for serverless might be. So here I logged into the demo.epsagon.com. This is an open environment. Everyone can feel free to reach it now or afterwards to follow what I'm doing. And we'll review just a bit out of what Epsagon offers, just the one that we actually reviewed in the observability pillars. So starting with the functions list, in here you can see the list of all of your functions from all of your AWS accounts, regions, and runtimes, to see for every function the trigger of it, and see the function name, obviously. Now you want to see performance metrics for each and every function, so starting from invocations and errors, also to detect timeouts and out of memories, which we already saw that they are unique property for a function as a service. See the last invocation, see the average duration, and see the monthly cost that we already saw before. But for example, let's say I want to see where the cost really spikes high, and I need to monitor that. I need to make sure my business not cost too much for me. Now, let's say I want to troubleshoot a specific problem in my system. So I'll start by the errors, and I'm seeing that I've got a blog site production application in here. You can see all these functions starting with blog site. The one that we will troubleshoot today is the post analysis. So this blog site offers two endpoints, one for users to read the blog post, and the other one for editors to upload new posts. And one part of the chain of processing a new blog post, is to analyze it to get some tags, extract some metadata, and so on. So for this function, we'll be able to see the amount of invocations and errors, the memory usage and the duration statistics all being presented in percentiles. So for example, in the last 24 hours, I might notice some spikes. Actually, it's for real in this application. Instead of serving a request under 33 milliseconds, all of a sudden we've got 1% of request that was being served for more than 2 seconds, and it's bad. And this is, by the way, why you should look also at percentiles and not just max, because max can be a high number, but it doesn't really match the surface.
To find all those edge cases that
exactly. Now, below that, you'll be able to find the invocation list, as we promised, including the AWS request ID for each and every function, the involved resources, the time that it happened, duration, used memory, and status. Everything here is filterable, so we'll be able to filter this extensive duration or a specific status or a timeout. Now, specifically in my case, I would like to troubleshoot a specific invocation. I know that somebody told me this invocation has been erroneous, and as we can see here, it's being filtered very easily.
So filtered by the request ID.
Exactly. Now, the first thing, as we saw after monitoring, is logging. So let's get the log of this function. Usually, it could be a nightmare to look for a specific log in CloudWatch log, but here the log is being brought to us. Now, instead of seeing, I can see the logs. It's pretty nice. I can see the traceback over here at division by 0 error. And I'm a great developer. I might be able to fix it, but I would never understand how did I got to this point where it fails. So instead of just seeing logs, we're gonna jump to the distributed tracing, or what we talked about, visualizing this story much more simply. So when we're clicking on this invocation ID, the transaction is being exposed to us. Starting from the Lambda that we just talked about, the post analysis, we can see all of the invocations. And remember that we talked about these attempt numbers, these attempts, and now you can see that because the Lambda failed, we see attempt number 1, 2, and 3.
This is the SNS retries after the function failed for the first time.
Exactly. So the SNS triggered the Lambda, it fails, so it has a built-in mechanism to retry that. We saw this, that in this time, all invocation ended in the same error. But now, as a developer, I would love to know what was the event that the SNS would send to my Lambda function. So I'll be able to click on it and see the full notification message. So in this example, I can see the full payload of the notification message, which is great for troubleshooting. Now I can see that the user was not authenticated for some reason. Now, if we haven't talked about distributed tracing and we talked just about nice visualization, it could end up here. But since we're doing distributed tracing, we're also able to see who published that message that got into the SNS and triggered the post analysis. And in Epsagon, since we're doing it automatically for you, you'll be able to click on the previous Lambda and also see for that Lambda that published the message, see the log, see all the return value and the event data. But honestly, what we're seeing already, and I guess you all eager to understand what bad happened, is that Auth0 is marked in red for some reason. So we'll be able to click on that as well as an HTTP request that is not even in AWS, but it's part of our application because this handles every authentication that we're doing. So in this example, we got a 401 status code. So as you all know, 401 is unauthorized. And as a developer, the next thing you'd probably want to do is add some prints, redeploy, and wait for the problem to happen again. But Epsagon doing automatic instrumentation, and it catches all the relevant information for you, including the response body. So for example, we'll be able to see that Auth0 responded to us 401 because we've got expired JWT. So our token is expired, and it means that we're not handling it very correctly in the request processor. Although we got 401, we still stream a bad or malformed message to the SNS, and that's why the second Lambda gets broken. Now this applies for any resource that we would click over here. We'll be able to see the headers for the API gateway or any other AWS resource that could have been participated in this transaction will be shown here for you. Now, sometimes you also want to search for traces or search for logs, actually. We talked about logging, so I'm coming back for that for a quick. So you'll be able to filter almost anything that happened, and since everything is structured, so you'll be able to filter by resource name, resource types, or even some more extensive example. For example, I would like to filter by a specific authorization header, so to match a specific user, or
yeah, maybe we want to know like how many times the unauthorized really happened in our system. Maybe you can just search for. I'm not sure this will work, but this is part of the message. No, so let's try to find that exact.
Yeah, so for example, I can filter maybe only for errors in my functions or errors in my resources, and I'll be able to see all errors that happen. And since I don't want to filter all errors, I can filter any specific method in the error. So for example, the zero division error or anything else that happened in the system. Now, last but not least, we talked about the notification rules. So AWS is great, but sometimes you want to get out of the box with all kinds of errors, timeouts, and out of memories, and exceptions, and even insights directly to your Slack or directly to your Microsoft Teams or Webhook or PagerDuty. So everything here can be easily managed through the Epsagon console and comes out of the box for you to get that. So I think that was our live demo of Epsagon. Before we finish, we just want to have a quick summary for you. So as you all know, and I guess we're seeing lots of attendees, it means that serverless is here to stay, and it's great. You can build amazing stuff very quickly, and it's like the modern agile of development. I think, though, that it brings some new challenges. Yeah.
I think that there are new challenges with serverless, and we just need to adapt to them, and they come in terms of monitoring and troubleshooting. But there are the right ways to tackle them, and the right tools out there to use them.
Yeah, I think so. You need the right tools to use them, and also I think you need to learn about it more, because just getting into some new topic, it's good for starting, but if you want some extensive information or to get into these kind of things, you need to take it right and understand and learn about it. So actually, Stuart is having a great course as part of Cloud Academy. If you want to share some information, Stuart.
Yeah, so I created this course last month. It's available in our library as of today, well, as of a couple of weeks ago. And it looks at AWS Lambda from kind of the beginning to kind of intermediate level. So if you're starting to work with AWS Lambda or already using Lambda but want to know a bit more about it, then this course will be certainly for you. Covering some of the learning objectives of it, you'll be able to explain what AWS Lambda is and what its use cases are. You'll be able to define the components used within Lambda. You'll be able to explain the different elements of a Lambda function through its creation, and I'll go through a demonstration in the course on how to create your function from scratch. You'll understand the key differences between the different policies used within a Lambda function, and you'll recognize how event sources and event mappings are managed for both synchronous and asynchronous invocations. And I'll also look at CloudWatch, how you can use that to monitor metrics and logs, some of which were discussed today, and how to check for common errors that might be causing your functions to fail. So it kind of covers a range of elements of the service. So if you're new to Lambda, or if you've just kind of started working with it and you're looking to gain a bit more insight into the service and what it's used for and how it runs and how to configure it, then come check out the course.
Sounds really interesting, promising.
Thank you.
Perfect. So it's time for Q&A, guys.
Yeah, so let's take a look, see what questions we have come in. So we've got a question here. What kind of data does Epsagon know to collect and how?
So that's a great question. And we actually talked about the automated instrumentation. So rather than the developer needs to automatically collect everything for himself, Epsagon collects all the relevant operations. So any operation against AWS resource, such as DynamoDB, API Gateway, S3, and you can name probably almost 1,000 services. So everything will be traced for you, and for each one of them, Epsagon extract the relevant information. So for example, for DynamoDB, it will collect the key and the item. For API Gateway, it will collect the headers, both of the response and the request. So the right information is being collected. Now, this is using a technique called the instrumentation, which behind the scenes collects all of these operations automatically for you. So it's being differentiated from one language to another, each one with its own technique to detour this information to us. But everything is taken care automatically for you.
Okay, excellent. Next question, is AppSync tracing support on the roadmap for Epsagon?
Actually, it's already supported. So you'll be able to see for AppSync the triggers, the Lambda. You'll be able to see the AppSync trace. So you'll be able to see that AppSync called the Lambda with the proper event and what happened. Unfortunately, for at the moment, AppSync that does not involve any Lambda function will not be traced, but it's definitely on our roadmap for this year. So stay tuned for whoever asks this.
Excellent. Another question, in which ways can I instrument my code with Epsagon?
So you can instrument in various ways. I think the most common one right now is just using auto instrumentation. We offer inside the dashboard in a one click to using the Epsagon, the AWS layers. We auto instrument your functions. Another way is to manually instrument. In our documents, it's just in Python, it's a matter of just using the Epsagon library and using the wrapper, the decorator to on top of your main function. And another way is using the serverless plugin.
Yeah,
most of
the people we see that they use the serverless framework because it's easy to get started with it. So we got a pre-built plugin that you just add 2 lines of configuration and everything is taken care of for you automatically.
Okay. Next question. We've had a question, I think it's related to the first one. Does Epsagon trace every process run by the application?
So I wouldn't actually call it a process. It's more of any operation that Epsagon supports. So you can see Epsagon got these libraries open source, so you can see what we support and what not. So it varies from AWS resources request to HTTP requests. So for example, for Node, we support fetch and got and request and HTTP and so on. It also supports MongoDB and Redis and Kafka. So the list can go more and more, but we constantly add support for more and more processes or operations on our roads.
Yeah, and we usually get input from our clients that say that some library is not being covered, and we also try to add that in. We prioritize that way.
Yeah.
Okay, excellent. Couple more questions here. Is there any performance impact when adding Epsagon into my functions?
That's actually a great question and concern for everyone because you're being billed by the duration, and also you don't want to affect the performance of your own customers since you're using Epsagon. But we managed to reduce it to a 5 milliseconds additional impact. So every invocation will send the traces when it ends, and it takes 5 milliseconds. Just, as a crowd, to be aware what happens behind the scene, we deployed the collectors, the Epsagon collectors in every region in AWS, and our library automatically detects where the Lambda function is running. I mean, in which region the function is running, and it sends all the traces to the closest collector out there. So that's how we accomplish really quick time, and minimum impact in performance.
Okay, thank you. We've had a couple of questions regarding support for multi-cloud. So can this be run across multiple cloud vendors? For example, can you pull serverless metrics from both AWS and Azure at the same time and view in the same dashboard?
Yeah, this is a great question, and I'm also a big believer in multi-cloud environments. So at the moment, for function monitoring, the function page that we saw, it's supported only by AWS or for AWS functions. But the tracing library supports any environment, and I actually mean it, any environments. We've got customers that running some Python code or even Go and Java code running on servers, even on-premise servers that is not related to AWS or any cloud vendor, that they're also being instrumented. So the library does support any environment, going from on-premise all the way to containers in any cloud or on-premise, while the function list is currently only populated from the AWS metadata.
Yeah, we also added recently support for Google Functions in our Python library.
Yeah, so we're looking forward to expand more and more, but currently the most supported environment is for AWS.
Excellent. Okay, I think we've got time just for a couple more questions. Can you fine-tune the instrument that Epsagon injects inside Lambda to send only particular requests?
Yeah, so at the moment we capture all of the supported libraries, but we do allow the user to skip the data. So it's actually called the flag of metadata only. So by default, we collect only metadata about these operations, from the timestamp that they happen, for how long that they happen, and some unique IDs that allows us to build this distributed tracing. And if the user selects to send metadata only, this will only be captured. If he selects to use not metadata only, like to set it to false, so we also collect some more relevant information, really great for debugging. So request headers and payloads and some more. By the way, I just wanted to let you all know, and you as well, Stuart, that Epsagon is also built on AWS. So actually data remains in AWS in the same region. And we also ISO 27001 certified and SOC 2 certified. So we make sure that this sensitive information that can include sensitive data is kept at the best standards that can be.
Yeah, that's good to know. That's important to people.
Yeah.
So one last question just before we round up the webinar. How often are the metrics gathered? Every minute, every second, every invocation? How does that work?
So it's almost for every invocation. I think that every invocation arrives to Epsagon in a matter of second or two. So you can see the logs, can see the invocation, can see be able to filter on it. Traces usually takes a bit more time because it being ingested in a longer processing pipeline. But in general, it's a matter of 5 seconds, 10 seconds until you can see this visualization out of the invocation.
Excellent. Thank you very much, guys, for taking those questions. So we'll just finish up the webinar now. So I just want to say thank you for everyone for joining us today, and a special thanks to both you guys, both Ran and Hen, for the insight across serverless monitoring and troubleshooting. There's been an awful lot of useful information, and it's a great demonstration as well to see the product in use and how it can really help. Just as a reminder to everyone, everyone will receive a recording via email as soon as it's available. And don't forget to check out all our other webinars, which you can find on our website at cloudacademy.com. Thank you. Do you have any final words, guys?
Thank you so much for having us. I think we had fun.
Yeah, we had some fun talking about serverless.
We're open to get any feedback from any guys here that been in here. And
yeah, thanks.
It's definitely a big topic in the industry at the moment. So thank you, guys.
Thank you very much, Stuart.
Speak to you soon. Thank you. Bye.
Bye.